10th Standard Algebra, Chapter 2, Quadratic Equations, Module-3. In this module, we'll see on how to find the solutions of a quadratic equation by completing the square. When the quadratic equation is in the form of x squared plus bx plus c equal to 0, this can be written as x squared plus bx plus b upon 2 the whole square minus b upon 2 the whole square plus c equal to 0. So here what we do is we add and subtract the term b upon 2 the whole square. Then we just rearrange this and we write x plus b upon 2 the whole square equal to, we'll take the minus b upon 2 the whole square and plus c on the other side. So we get the minus will become plus, we get plus b upon 2 the whole square, and the plus c when you take on the other side will become minus c. Now we just solve the above to get the solution of the quadratic equation. We'll start by solving sums of practice set 2.3. Solve the following quadratic equation by completing the square method. The first sum is x squared plus x minus 20 equal to 0. So now in this particular quadratic equation, if we compare the coefficients, we get a equal to 1, that's the coefficient of x squared, b equal to 1, coefficient of x, and c, that is the last constant term, that is minus 20. Now what we have to do is we just have to add and subtract b upon 2 the whole square. So b is 1 and 1 upon 2 the whole square will become 1 by 4. So here we have just added 1 by 4 and subtracted 1 by 4. Now by using the formula x plus b upon 2 the whole square is equal to b upon 2 the whole square minus 2. We'll just rewrite a quadratic equation in this particular form and then simplify it. So x plus 1 upon 2 the whole square minus 1 plus 80 upon 4. So this is just the right hand side which is rearranged. So we have just taken the LCM. So here if we solve it further, we get as minus 81 upon 4. Now if you take minus 81 upon 4 on the other side, we get x plus 1 upon 2 the whole square is equal to 81 upon 4. Now taking square roots on both the sides, we get x plus 1 upon 2 is equal to plus or minus 9 upon 2. So we can just separate it as x plus 1 upon 2 is equal to 9 upon 2, or x plus 1 upon 2 is equal to minus 9 upon 2. If we take plus 1 by 2 on the other side in both the cases and we just solve it, we get x to be 4 and minus 5. So the solution of this quadratic equation is 4 and minus 5. We'll solve one more sum of completing square method, and this is the second sum of the same exercise. The sum is x squared plus 2x minus 5 equal to 0. If we compare this with the general form, our a will be 1, b will be 2, and c will be minus 5. b upon 2 will be b is 2, so 2 upon 2 is equal to 1. And if you take b upon 2 the whole square, that is 1 square will remain 1 itself. So we know we have to add and subtract 1 on both. Add and subtract 1. Now by using the formula x plus b upon 2 the whole square is equal to b upon 2 whole square minus c, we'll write a quadratic equation in this form and we will simplify it. So if we have added and subtracted 1, x squared plus 2x plus 1 minus 5 equal to 0. So we'll write it in this form. So x plus b upon 2 is 1, so x plus 1 the whole square, and minus 1 minus 5 will give you minus 6. So now if you take minus 6 on the other side, you'll get x plus 1 the whole square equal to 6. Now you take square root on both the sides. So it becomes x plus 1 is equal to plus or minus root of 6. And we'll just separate it. X plus 1 is equal to root 6, or x plus 1 is equal to minus of root 6. Take plus 1 on the other side in both of the cases. So we get x to be root 6 minus 1, or x is equal to minus of root 6 minus 1. So the two solution of this quadratic equation is root 6 minus 1 and minus root 6 minus 1. We'll do one more sum, and the next sum is m squared minus 5m is equal to minus 3. So this, what we'll do is, first we'll just rearrange this. We'll take the minus 3 on the other side. So we have m squared minus 5m plus 3 equal to 0. This, if we compare it with the general form of the quadratic equation, we have a as 1, we'll have b as minus 5, and we'll have c as 3. Now we'll try to use the formula x plus b upon 2 the whole square is equal to b upon 2 the whole square minus c. So I'll write my quadratic equation in this form. So here I'll just use a variable m because in our question we have the variable m. So in place of x, just use a variable m. So I have m plus b upon 2. b is minus 5. So minus 5 upon 2 the whole square is equal to, same thing here again, minus 5 upon 2 the whole square minus c, but c is 3. Just rearrange this. So I have m minus 5 upon 2 the whole square is equal to, if you take the square of this will become 25 upon 4 minus 3. I'll just simplify the right hand side. We'll take the LCM. So you have m minus 5 upon 2 the whole square is equal to, so if you take the LCM, you will have here 25 minus 12 upon 4. We'll simplify this further. So this will be m minus 5 upon 2 the whole square is equal to 25 minus 12 will give you 13 upon 4. Now we take square root on both the sides. So if we take square root on both the sides, this will become m minus 5 upon 2 is equal to plus or minus root of 13 upon, and you know that square root of 4 will be 2. Now we'll just separate it. So you have m minus 5 upon 2 is equal to plus root 13 upon 2, or m minus 5 upon 2 will be equal to minus root 13 upon 2. Now in both the cases, take minus 5 upon 2 on the other side. So you will have m is equal to root of 13 upon 2 plus 5 upon 2, or m is equal to minus root 13 upon 2 plus 5 upon 2. Now in both the cases, they have the same denominator. So you can just write it like this: root 13 plus 5 upon 2, or m is equal to minus root 13 plus 5 upon 2. So the roots of the quadratic equation is root of 13 plus 5 upon 2 or minus root 13 plus 5 upon 2. Now we'll see another method to find the roots of our quadratic equation, and that method is called as a formula method for solving quadratic equations. So for a quadratic equation ax squared plus bx plus c equal to 0, we can use this formula to find the root of any particular quadratic equation. So we'll use a formula. The formula is x is equal to minus b plus or minus under root of b square minus 4ac upon 2a. So we can separate this as, first root will be minus b plus under root b square minus 4ac upon 2a, and another root will be minus b minus under root of b square minus 4ac upon 2a. So one of the roots I'll call it to be alpha, and the other root I'll call it to be beta. Let us solve the sums of practice set 2.4 that says compare the given quadratic equation to the general form and write the values of A, B and C. If we see in this particular question, we just have to find out the values of A, B and C. So if you see the first, if we compare it with the general form, so coefficient of x square is 1, so A is 1. Coefficient of x is minus 7, so B is minus 7, and the last constant term is 5, so plus 5. If you see the second one, coefficient of m square or the square term is 2. Now, the coefficient of m, if you rearrange this, you see first we'll rearrange this, so you have 2m square minus 5m plus 5 equal to 0. Now you will able to tell me b. B will be minus 5 and c, the last constant term, will be plus 5. If you look at the third one, it is y square is equal to 7y. So I'll just rearrange this. So this will be y square minus 7y equal to 0. Now you can tell me a will be coefficient of the square term. In this case it is 1. B will be coefficient of y term. In this case it is minus 7. And the last constant term is absent. There is no constant term. So you can say C will be 0. Okay. Now we will use the formula and we'll solve one sum, and this is the question 2 of your practice set 2.4 that says solve using the formula method. So the first sum is, this is x square plus 6x plus 5 equal to 0. First, whenever we are solving such type of sums, you first write down values of a, b and c. So in this case, a is 1, b is 6 and c is 5. Now, if you remember the formula, in the formula we had the term b square minus 4ac. So we'll just find out this term separately and take the square root of it. So square root of b square, that is 6 square, minus 4 into a, that is 1, and c, that is 5. So 6 square is 36 minus 4 into 1, 4. 4 into 5 will be 20. So it will be 36 minus 20, and that is 36 minus 20 is 16. And we know square root of 16 is 4. Now we will use the formula, that is x is equal to minus b plus or minus square root of b square minus 4ac upon 2a. Now we'll just substitute the values. Minus of b, that is 6, plus minus under root of b square minus 4ac we just found out, and that is 4 upon 2 into a, that is 1. So this will be minus 6 plus minus 4 upon 2 into 1, that is 2. Now we'll just separate it. So this will be minus 6 plus 4 upon 2, or minus 6 minus 4 upon 2. So this will be minus 2 upon 2, or this, and this will be minus 10 upon 2. So this, if we simplify this will become minus 1 and this will become minus 5. So the two roots of this quadratic equation is minus 1 or minus 5. Let us solve one more sum by using the formula method. So in this sum, the quadratic equation is x squared minus 3x minus 2 equal to 0. So always remember, first you find out the values of a, b and c. So in this case, a is 1, b is minus 3 and c is minus 2. Now then you find out a value of b square minus 4ac. So in this case, b square is minus 3 square minus 4 into a is 1 and c is minus 2. So this will be minus 3 square is 9, and if you see this minus and this minus of minus 2 will give you plus, and 4 into 2 is 8. So under root of 9 plus 8. So 9 plus 8 will give you 17. So the 17 will keep it as it is, and now we will use the formula. The formula is minus b plus minus under root of b square minus 4ac upon 2a. Substitute all of the values. B is minus 3, so this becomes minus of minus 3 plus minus under root of b square minus 4ac, and we just found out under root of b square minus 4ac is root of 17 upon 2 into a, that is 1. So if you see, this minus into minus will become plus, so you have plus 3 plus minus root of 17 upon 2 into 1, that is 2. Now we just separate it. This becomes 3 plus root 17 upon 2, or 3 minus root of 17 upon 2. So the roots of a quadratic equation is 3 plus root 17 upon 2, or 3 minus root 17 upon 2. We'll solve one more sum, and this is solved by using formula method. Y squared plus 1 upon 3y equal to 2. So this is just little bit different. We have to just write this in the normal form of a quadratic equation and solve it in the same way. So first, if you take the LCM on throughout, so you get 3y squared plus y minus 6 equal to 0. Now if you compare this with the general form, you have ax squared plus bx plus c equal to 0. So you have a as 3, b as 1, and c is equal to minus of 6. We find out b squared minus 4ac, b is 1, so 1 squared minus 4 into a, that is 3, so 4 into 3 into c, that is minus 6. We solve this, you get 1 plus 72, which is 73. Now use the formula y is equal to minus b plus minus under root of b squared minus 4ac upon 2a. Substitute all the given values. B is 1 plus minus b squared minus 4ac is 73, so that becomes under root of 73 upon 2 into a. So a is 3, so you have 2 into 3. Now you have 2 into 3, 6. Now what you do is you just separate it. So the roots of this quadratic equation is y plus minus 1 plus root 73 upon 6, or minus 1 minus root 73 upon 6.